All right, so today we're talking about 2.8, combining and composing functions. Let's go to work. First, we started talking about combining functions. And combining functions is simple operations of addition, subtraction, multiplication, division. We'll get into these a little bit more deeper here in a minute, but combining functions, we're just going to basically put functions beside each other with these four different operations. Composing functions a lot of times is called when you take a function of a function. And a lot of people get confused there because you don't necessarily know where to start. I'm going to go ahead and tell you right now, you're going to start inside out. Inside out. And we'll talk about those specifically. And then finally, you're going to find the domain of the combined and composed functions. Well, that's no different than any other time that we found a domain. What's another name for domain? The x values or the input or the independent variables, okay? It's going to be the same. It's just once you've combined or composed the functions, you're going to be looking to see if there's anything that we cannot put in, okay? So there's some proper mathematical what it looks like when you're going to add, subtract, multiply, or divide. But I'd like to do a few where we add, subtract, multiply, or divide. Okay. We'll come back there. So let's start with example number 1. Example number 1, we're just taking f plus g. In other words, here's f, here's g. Okay? We're going to add them together. So that means we're going to take x squared minus 4. We're going to add it to x squared minus 6x plus 8. Basically, we're combining like terms, right? I got an x squared and an x squared. So x squared plus x squared is 2x squared. I have no other x values, so I'm just going to bring it down. Plus a negative becomes a negative 6x. And then finally, my two constants. Negative 4 plus 8 is a positive 4. So f plus g of x is 2x squared minus 6x plus 4. What would the domain of this function be? It would be all real numbers because there's nothing I can't put in there. You see that those are the exact same things or the same process we've been doing anyhow. Correct? And then this portion right here where we actually added these, well, that goes all the way back to Algebra 1, combining like terms. Yes? All right, so what does this mean? This f of g of negative 4, f plus g of negative 4. It just means now we're going to plug negative 4 in to our new function. So in this case, we would have 2 times negative 4 squared minus 6 times negative 4 plus 4. Negative 4 squared is 16. 2 times 16 is 32. Negative 6 times a negative 4 is a positive 24. 32 plus 24 plus 4 is 60. So we combined the function. We found the domain of the function. And then we evaluated the combined function at negative 4. Think you can handle it? Let's try another one. Let's say we were to subtract them. Somebody give me f of x, please. And g of x, please. squared minus 6x plus 8. Okay. This one's slightly trickier only because it has that negative. Remember, when you're plugging anything in, I don't care if you're talking about plugging something into a simple equation or here where you're combining functions, don't forget to put a parenthesis around it. So I got now x squared minus 4 minus x squared minus 6x plus 8. That parenthesis is very important. Now, I don't know how you do it. You know, do you take that -1 and you distribute it to all three of those? Or do you just use your knowledge and deal with your signs as you come about them? I don't know. I just deal with my signs. So, for example, I got an x squared minus x squared. Those cancel. I don't have any other x's, but now I have a minus a negative x, which is a positive 6x. And then I have a -4 minus a positive 8, which is a -12. See how we combine those functions. All we did was combine like terms. Okay. So what is the domain? Again, the domain is all real numbers. Or you could list it, you know, we have been listing it like this, right? From negative infinity to positive infinity. It's probably the way we would stick with it. Most likely, I expect that's how your book will be asking. And finally, can we find the combined function f minus g of 0? Sure. We just plug a 0 in, which is 0 minus 12, which is -12. Nothing too hard there. Again, that was just simple addition and subtraction. What's going to happen when we multiply? What's going to happen when we multiply? We're going to have a new f and a new g here. So let's take it. We have now x plus 2 times the square root of 1 minus x. We distribute. We have x times 1 minus square root of x. And then we have 2 times 1 minus the square root of x. What is the domain? What can I not have in roots?
Negative.
Can't have any negatives. So this x,
Any number greater than 1.
is it greater than 1 or is it less than 1? Because we're subtracting it, right? So my domain must be less than or equal to 1. Or if we wrote it in function notation, it would be from negative infinity to 1, including 1. Can we evaluate this function now? Sure, we'll just plug it in. Plug it in, plug it in. 1 times the square root of 1 minus 1 plus 2 times the square root of 1 minus 1. So that's 1 times the square root of 0 plus 2 times the square root of 0, which is 0 plus 0, which is 0. Yes, dear. Oh, it is. And that changes it, doesn't it? Thank you. Okay, so I have a -1 here and minus a -1 and minus a -1. Thank you. All right, so I have -1 times the square root of 2 plus 2 times the square root of 2. Can I simplify that any further? Nope. Not unless I want to put a decimal, and I don't. Cool? Good. Thank you. All right, so I'm going to let you do D. I just want to see what you got. Give you just a second. See what you come up with for D. All right, so F goes on top. So in this case, we have x plus 2 divided by the square root of 1 minus x. Is there anything I can simplify there? No. So what's the domain? Oops, sorry. What's the domain? I can't have, I already said we can't have any negatives because it's under a square root. I also can't have 0. So I can't have 1 either, can I? So now our domain was less than or equal to 1, but now it's got to be just less than 1. Or from negative infinity to 1, non-inclusive. And finally, can we plug in negative 1? Sure. Negative 1 plus 2 over the square root of 1 minus the negative 1, which is 1 over the square root of 2. Now, if you wanted to rationalize the denominator at this point, so we got rid of the square root, we could. I'm not going there right now. What do I mean by rationalize the denominator?
Getting out of the square root.
Yeah, we don't like square roots on the bottom. But, let's do it for fun. Let's multiply it by a square root of 2 over the square root of 2 to get square root of 2 over 2. That was pretty simple, yeah. All right. Next is composing functions. Taking a function of a function. Okay? Take a function of a function. You need to remind yourself that you're going to work inward out or inside out. Start with an input for x. You use it on the inside function. And then take that new value and do it on the outside function. All right. So here we have two functions, f and g. When I'm writing these down, just to show with writing, I always start with the inside one, the second one. The second one is going to be your inside one. So I always like to write it down first. So 1 plus x squared. And I put a parenthesis around it. Now, the best thing you can do is at this point is to just think of this as that whole thing as an x. If you think of it as an x, then you can put it into the second one. So I have 1 minus 2 times whatever's in that set of parentheses. Does that make sense to you? So your composed function looks like this. 1 minus 2 times 1 plus x squared. Now, here they're asking me to find f of negative 2. So I start with the inside function, 1 plus negative 2 squared. 1 plus negative 2 squared is 1 plus 4, which is 5. So now I have 1 minus 2 times 5. Notice we did the inside function first. Now we're doing the outside function. 1 minus 10, which is a negative 9. So the composed function f of g of negative 2 is 9. And here's the one interesting thing about not only composition function or composed functions like this one, but also the combining functions that we just did, is they're not commutative. There's a big word. Evan, what's commutative mean? Do you drive to school? What's another name for your drive to school or to work? Your commute. The commutative property means when you drive to school, where do you live? Philly? So you start at Philly and you drive down, say 416 through Tuskegee, and you end up at Janayton. When you go home, you start at Janayton, you go through Tuskegee and back to Philly. Notice that everything is in opposite order. Well, that's what the commutative property says, is 3 plus 4 is the same thing as 4 plus 3. Notice the order is just different. It's backward, right? That's commutative property. Well, these things are not commutative. Addition's commutative and multiplication is commutative in the real world, like 2 times 3 is the same thing as 3 times 2. Yes? Okay, so we just found f of g, and we found the value of it. Watch this. What is g of f of negative 2? Well, I told you we start where? On the inside. So now my inside would be 1 minus 2x. Put a parenthesis around that. And then what's my other function? 1 plus, and this thing is x squared. Do you see that? All right, now if I plug in now negative 2, we start with 1 minus 2 times negative 2, which is 5. Now I have 1 plus 5 squared. Well, 5 squared is 25 plus 1 is 26. Notice those are not the same. Therefore, these functions, composition functions, are not commutative. They're not going to work the way. Just because you can do it one way, when you do it the other way, you're going to get something totally different. And that's what one of the things that makes these so confusing for so many people. Okay. So moving on, what was f of g of x? Well, that was 1 minus 2 times 1 plus x quantity squared. What's the domain of this function? I can put anything I want in for that x, right? There's no limitations. There's no roots. There's no fractions. Nothing limiting me. So from negative infinity to positive infinity, or all real numbers. Whatever floats your boat. Let's go to example 2. Nope. Let's go to this one. I want you to look at those. Let's go with this. Let's say f of x equals x squared. And let's say g of x equals 2x plus 3. Got those two functions? I would like you to find all four of these, A, B, C, D, A, B, C, D, given those two functions, please. All right, what do we write down first? Caden?
For A,
Yes.
I wrote down f of g. Is that how you say it?
Mm-hmm. F of G.
F of g is 2x plus 3 plus squared. Like the 1 in
Okay.
the x.
Two times one is
2,
plus 3 is
5,
5 squared is.
25.
How many people got that? Excellent. Excellent. No problem. So what's the domain of this function? All real numbers. Which is the same thing as saying from negative infinity to positive infinity. All right, same two functions. Now find the inverse. Or not the inverse, excuse me. That's not proper. Find the opposite or the backward of it. Cole, you get that one done?
Yeah.
Go ahead.
I have 2, and then times 1, and then plus 3. Or times negative 1, yeah. And then x squared in parentheses. But negative 1 is into the x. And then I got 1.
All right. If I'm writing it down, first thing I'm writing down is F. Oops. I don't want to lose that. I'm gonna write down f. F is x squared. Excuse me, x squared. And I'm going to put a parenthesis around that, and I'm going to treat that as my x. Now, what's my g? 2 times x plus 3. So it should look like this. So then you got 2 times -1 squared plus 1. -1 squared is 1. 2 times 1 is 2. 2 plus 3 is 5. See the difference?
Yeah.
Okay. Questions on composing functions? Think you'll be able to handle it? Composing looks really hard at first, doesn't it? But not actually.